Alright, here's a quick video on lesson 72, graphing exponential functions. We've been talking so much about exponential functions and logarithmic functions that I thought it would be nice to take a look at the graph. What we want to do first is we're going to be using our calculator table. We don't need to, but I want you to know how to use it. So what I'm going to do is I'm going to pull up my calculator, and we're going to use the table to find some nice points in the function 3 to the x. So we go into our y equals, and we're going to 3 to the x. X is this button next to alpha, right? Diagonal from the second button. 3 to the x. We're going to hit second and then table. And I want to make sure from some settings before that mine is on the defaults. Okay, now we're good. So from y equals, I'm going to hit second, table. Now, we'll see some nice points and some ugly ones. Now, when I scroll into the negatives, I see a bunch of really ugly decimal points. I'm not going to be able to graph these points by hand. These seem very, very small and not very accurate. So let's find some points, scroll up and down until we find some points that we can graph. All right. Now, here are the points that are going to be nice to graph. So my x values to these nice points are 0, 1, 2, 3, 4, 5. So let's start with those. 0, 1, 2, 3, 4, and 5. My y values are 1, 3, 9, 27, 81, and 243. Now I want to explain real quick where these values come from. These are not some mystery values. What we're saying is for these x values, let's plug them into the function 3 to the x, so that becomes 3 to the 0. And here it'll be 3 to the 1, and 3 to the 2, 3 to the 3, 3 to the 4, and 3 to the 5. Well, anything to the 0 power is, well, you guessed it, 1. 3 to the first power is itself, which is 3. 3 squared, well, that's 9. 3 to the third, that's 3 times 3 times 3, which is 27. 3 to the fourth is that times 3, which is 81, times 3 again would get me 243. Right? So these are the points that we can graph. Let me erase all this right here, okay? So these are the points that we can graph. 0, 1, 1, 3, 2, 9, 327, 481, and 5, 243. Now most of these are a little too big. Right? So these are the ones that I'm going to focus on here. I'm going to go to the back of the sheet, and what I'm going to do is I'm going to graph these points. And the points, remember, are 0, 1, they are 1, 3, should be right here, and 2, 9, which is all the way up here. $327 would be like way up here. It's way off the graph. I'm not going to be able to graph 3,27. But so here's what I do know. It seems like it's climbing, and it seems like it's climbing faster and faster. So from this point up, right, let's draw a little curve. And if I draw a curve to here, I know it's just going to get steeper, and it'll end up looking like this. Now, I want to talk about what happens on the left side, what happens over here. These are my negative x values. This is x is -1, -2, -3, and -4. So I want to go to a sheet of scrap paper, and I want to talk about what happens for these. Now, remember that my function is y equals 3 to the x power. And I want to know what happens for those negative x values. So I'm talking about -1, -2, -3, and -4. So the function in this case is 3 to the x, which is 3 to the negative 1. This would be 3 to the negative 2, 3 to the negative 3, and 3 to the negative 4. A negative exponent, right? A negative exponent is a 1 over. So what that means is if I use this, it will turn the 3 to the negative 1 into a 1 over 3 to the 1. 3 to the 1 is just 3, so this is 1/3. The negative, once again, is a 1 over, so this is going to become 1 over 3 to the second, 3 squared. Well, 3 squared is 9, so this is 1 over 9. 3 to the negative third is going to be 1 over 3 to the third, which is 1 over 27. And I'm sure you can see the pattern by now. 3, 9, 27. If you look at the table on the front, you would know that what comes next, 1 over 3 to the fourth, that's going to be 1 over 81. Now what's happening here is as I'm going to the left, right, let me highlight that, right, these x values are going to the left, negative 1, negative 2, negative 3, negative 4. These are getting smaller. But they're never going to go negative. 1 over 243, 1 over 729. These are getting smaller, but not negative. So they're getting smaller and smaller and smaller, but they're going to 0. They're not going to cross the x-axis. They're never going to become negative. So I'm looking at this on the graph, right? I know that these numbers are getting smaller and smaller, but they're never going to cross. That's a no-no. It's not going to cross. Right? They're getting smaller towards the x-axis, and that is all they're doing. It is important that you do not cross the x-axis because the x-axis is what we call an asymptote. And let me give you that definition. The domain of this function, the range of this function, and the asymptote definition. The domain is my left and right. The domain is my x values. So what we're saying here, the domain, we're saying for what x values is the function defined? So let me look. For what x values? Well, it goes forever to the left and it goes forever to the right. Right? See over here, it's going up and to the right. So this goes to negative infinity and infinity. The range is my up and down. Those are my y values. So let's see. Does the function go up and down forever? Well, I mean, it certainly goes up forever, but it doesn't seem to go down. It only goes down to, well, 0. So it just goes from 0 to infinity. So that's my range, from 0 to infinity. Now an asymptote is a line that a function approaches but never crosses. It's a line that a function approaches but never crosses. So that is a very messy word. In this case, the asymptote is the x-axis. It approaches it, but it's never going to cross it. Another way of writing the x-axis is the line y equals 0. That, in this case, is the asymptote for this function. Now, there are two things that we'll get into later on, and I just gave you some short notes on it. Get into it a little later on. That'll change the asymptote, that'll change the range, right? And these are vertical shifts and horizontal shifts. A vertical shift happens on the outside of the function, right? So if I took 3 to the x, I would just put a plus 2 on the end. That would move it up 2 units. Minus 2 would be down 2. For horizontal shift, those are on the inside right next to the x. So if I wanted to do a horizontal shift, that would be a little minus 4 right next to the x, which happens to be in the exponent spot. Now, horizontal shifts go in the opposite direction than you would think. So sideways shifts, right? So a minus 4 you would think makes it go that way, but it doesn't. A minus 4 makes it go right. Okay? So horizontal shifts go in the opposite direction you would think. So to the right is actually a minus, and to the left is actually a plus. So for example, what I'm saying is if I instead did 3 to the x plus 1, that would be left 1 unit. Okay, I hope that helps. That's really just me reminding you of some stuff from Algebra 1. If you have any more questions on that, really, in order to graph any of these functions, what you're going to do is you're going to use the table in your calculator, and you're going to find some values that make sense, find some points that are easy. And that goes for things like 2 to the x, like 1/2 to the x, and also 1/4 to the x. So good luck. If you don't have a calculator table, that is going to be difficult, but you could always catch me in the morning and borrow a calculator. All right. Have a good night. Good luck. See you in class.